So seating people in a circle. Let's go back and visit our 7 friends from our warm-up problem. This was in the first video of this playlist on counting. That is the first video in the modules on counting. I am under the impression that if you're watching this video, you've seen that video. So Alan, Beth, Dolores, James, Marisol, Christina, and Rita all want to get together to complain about their dentist's poor appointment scheduling practice. They're pretty upset since all 7 of them came in and 4 of them were told they weren't going to be seen and just had to leave. They decide to go out to lunch at BJ's in Brentwood. Since they are a larger party, they get seated at a round table for 7. In how many different ways can they be arranged at this table? 2 seating arrangements are considered equivalent when each person has the same left and right neighbor. So in order to start off, let's draw a circle to get our bearings here. And let's draw the place setting. So here's 1, 2, 3, 4, 5, 6, and 7. And someone has to get seated first. So let's say Dolores gets seated first. Dolores is sitting right here. And now, how many ways can we arrange her neighbor? Well, there are 6 people left to choose from, so we can choose this first seat in 6 ways. This next seat has 5 choices. This next seat has 4 choices. Then here we have 3 choices, 2 choices, and finally just 1 choice. So by default, whoever wasn't seated in any of these seats gets the last seat. Now, how many total different ways can this be done? This is 6 times 5 times 4 times 3 times 2 times 1, which is 720. Okay, so you might be wondering, well, why did I seat her first? Why did I seat her here in particular? Well, I don't have to do that. What if we rearrange the seats? Well, if I rearrange the seats, you notice Dolores was sitting here originally. Now Dolores is here. And there are still 6 ways to choose this seat: 5, 4, 3, 2, 1. And we can keep going. I could put Dolores here, or here, or here, or here, or here. But as long as her neighbors are the same, these seating arrangements are all equivalent. So what you've just done is you've gotten rid of the equivalent seating arrangements. So another way to write this is there are 7 factorial ways to arrange people at the table, but 7 of these are duplicates. So this becomes 7 times 6 factorial over 7, which is just 6 factorial, which we already have above. This brings us to our final rule, the division rule. And please take a moment to read the definition in your book. I find that definition a little obfuscated, so I write it out more like an example. Suppose you want to complete a procedure and find n different ways to complete it. Then after some further inspection, you realize that d of the ways you came up with to complete the procedure are equivalent. So you thought you had n distinct ways to do it, but you really didn't, because d of the ways are equivalent. Then the total number of distinct ways to complete your procedure is n over d. And that's just what we did in the previous example, where we had 7 factorial over 7 to get 6 factorial ways to arrange the 7 people at a round table.